Hello everyone and welcome to another session of Digital VE Days. My name is Silas Zorn and I will moderate this webinar today. The topic of today's webinar is Digital Isolators, the next step in signal protection. Our speaker today is Timur Uludag, who is working as a product manager at World Electronic ISOs. Timur, hello, welcome.
Hi.
Cool to have you here.
Thank you to be here.
Before we start with the webinar, I would like to give you some more informations. You will be muted during this webinars. This means that you cannot ask us questions via your microphone, but you have the opportunity to ask your question into the chat. And then, after the presentation, Timur will answer your questions, and then we come to an end. So, last information from my side. You will all receive the link to the presentation as well as to the recording after the session today in the next days. So now I will hand over to you, Timur, and
Thank you.
I wish an exciting webinar.
Thank you. So first, thank you, Silas, for this good introduction. Let's start. So first of all, let us clarify a little bit more, because we're talking about isolation, why we need an isolation here for a data transmission. If you see here this picture, this is, let's say, a prime example for warehouse logistics. You have got here tens of meters of cables. You have got sensors. Let me try here. You have got here sensors that get all the parameters like temperatures, position, and speed. And all the data will be forwarded here down to the central control unit. And also you have got here a lot of interference sources like transients. You have got strong magnetic fields and a lot of distortions here. So what happens if, let's say, you measure here a temperature, and this temperature information will be some millivolts only, and it's going to be forwarded here to the central control unit. And the central control unit has a different potential than the sensor. Then the information can get lost because due to the fact that you have got different ground potentials. Or if you have got here a frequency converter and you have got here the communication bus lying not very good in the near field of these motors, then it can be that the pulses of the frequency converter directly couple to the communication bus. This can lead then to transients and to voltages that can exceed values, so that you can also be harmed and all the electronics can be damaged. Simplified, you can see it on the right here. Sensor, temperature, position, speed. You have got the communication path, and then you have got these disturbances here represented by an arrow. And this is going to be then to the central control unit and disturbs here. So if we now summarize all the, let's say, phenomena we have now got from the example application, then we can see that first, we need the isolation for a safety barrier between hazardous voltages and the user. Second, separation of ground loops between spatial circuits. Third, minimization of common mode interference. And fourth, interference-free data transmission. So first, let's find out how the signal isolation can be realized in general. We have got here device 1 and device 2. In order to meet the requirements of shielding dangerous voltages from the user, we need something that is a blocker, is an isolator between device 1 and device 2. The isolator here. The isolator here electrically separates device 1 from device 2 so that they can work independently. The data can flow through the isolator, but the interference and potential equalization currents are held back so that there are no disturbances from device 1 to device 2. So Word Electronics' new digital isolators are built on the capacitive technology. That means, in this case, the electric field changes with the level of charge on the capacitor plates. That means this charge is proportional to the level of the signal that should be transferred and is dedicated across the isolation barrier. But let's take a deeper look. How is it built up? The digital isolators here are manufactured in a standard CMOS technology process. The capacitors of the transmitter, here you can see, are laid on a lead frame. The capacitors themselves here in gray are formed between two horizontal contacts that we have here in red. The dielectric material between the capacitor plates also serves as a galvanic isolation. Let me show here and here, this yellow stuff. The digital isolation material is SiO2, so it is silicium dioxide. Both capacitors are connected here via a bond wire, so that you have got the first and the second capacitor in series. To protect now the whole structure here from the environment, we make a standard molding process and all is encapsulated and well protected. Now we know how it is built up. Let us now check out how the process, the function is to get the information through the digital isolator. Digital isolators transfer signals across an isolation barrier. This is achieved by using a modulator here on the left, then transmits a high frequency signal through the isolation barrier. And then we have got here the receiver that demodulates the high frequency signal to an equivalent signal that we have put in the input. So now we know why we need a digital isolator. We now know how it is working. We know how it is built up. Let's check out a little bit more what applications is standard for a digital isolator. First of all, industrial automation. Here we have got a lot of RS-232, RS-485, CAN buses, so standard industrial buses we have here that we can protect with a digital isolator. Second, solar and industrial power supplies. That means if we go for a telecom SMPS or an uninterrupted power supply, here the digital isolator is the bridge that gives the signal from the secondary side to the primary side. Last but not least, electrical vehicles, charging and electric meters. Here is it for charging stations, smart electrical meters to protect, because here we are working on high voltages and there we need a protection to the central unit and also to the person who is working with this. Let us now go a little bit more in depth for a real application that is shown here. The SPI bus here is a standard bus for synchronous serial communication designed to provide a simple and easy implementation of high-speed interfaces for, we have got here the microcontroller and, for example, and here the analog to digital converter. In the middle, you can see we have got here a reinforced digital isolator in a configuration with 3 forward and 1 channel on reverse with an integrated DC-DC converter. The charm here to have an integrated DC-DC converter is that all is compact and you have less board space you have to spend. And this is always quite nice for these applications. A second well-known application is a CAN bus. As you can see here, the digital isolator is here placed in the middle between the controller and the transceiver. As both controller and receiver can be referenced to different grounds, we need here the digital isolator to make here a ground loop breaking so that we have got here no interferences. Additionally here, because we have got here a 2-channel device, you need an external isolated power module to separate also the power passes here. Normally now, we got, if we were now in a face-to-face meeting, the question rising, yeah, but I know I can also use some optocouplers special for CAN. Yes, let me sort this out a little bit. If you have high-speed applications, then it is the best here to use digital isolators because let's say the transfer from the input to the output is not dependent to any temperature or any other effects. So for high speed, a digital isolator is absolutely preferred. If you have got somehow low speed data rate, then you can also use an optocoupler. But the speed means the megabits per second is not the only criteria here. It's also if you have got enough space or less space, if you have got a high channel count or not a high channel count, that somehow is also very important if you decide to go for a digital isolator or for an optocoupler here. So if we now go for an implementation of the digital isolator, there we sort out that there are some critical values, parameters you should be aware of when you make the design in. Here we have got the 6 main parameters you have to check out for the design. We start here with the data rate, overpropagation delay, and also, last but not least, the default output if you have got a high or a low value logic in your system. We also put here, for your better understanding, a small definition so that it is more tangible to see what is really behind this value. So, portfolio. Our current portfolio exists of 2 different types. We have got our CDIS. This is our standard digital isolator. This is without integrated DC-DC converter. The CDIP you see on the right here. Here. This P indicates powered, means here you have got an integrated DC-DC converter. Our CDIS is available in 2 different packages. We have got the SOIC narrow body and the SOIC wide body. The one with the integrated power we have in SOI 16 wide body. Now a little bit looking into the future, what's coming up next. We will soon expand our portfolio of the SOIC 8 with a SOIC 8 here, wide body version. That means we can upgrade the isolation voltage from 3750 volts up to 5 1000 volts RMS, because we have got here a special package that the pins here, where is it here, are a little bit wider than the one in the SOIC8 narrow body package. So now we know why, we know how we can implement, we know how the digital isolator is built up, but in emergency, the digital isolator should protect, should be a shield between dangerous, hazardous voltages and the person. And therefore, the digital isolators have to be robust and therefore have to fulfill the highest requirements in terms of safety and durability. Therefore, all our digital isolators are certified according to UL and to the VDE. Let us go here a little bit deeper. For the UL, we go for UL 5077. We have got here for the whole portfolio, we have got a single protection certification. And for the VDE, we took, from my perspective, the standard that makes the highest demands in durability and safety, the IC 6747-17. This is a quite new standard that comes up 2020, 2021. And there you can see this is a standard that is specialized for magnetic and capacitive coupler for basic and reinforced. For the SOIC 16 wide body, we got the reinforced isolation certified. And for the SOIC 8 narrow body, we have got the basic isolation certified. The certification was done by the VDE in Germany, in Frankfurt. For those who do not know the IC 6747-70, let me explain here a little bit only the philosophy. This philosophy of the standard is to test the reliability of the insulation over time with a destructive end-of-life test program. So there are a lot of parts in the qualification phase that are tested really, really hard. And additionally, to the 100% end-of-line test, all our products have passed. The IC 6747-17 also requires a sample test periodically to ensure the isolation capabilities over a time. That means every, let's say, a special amount of parts, we have to take it out, put it to the VDE again, and it is going to make an additional test for us so that we can say, okay, this part is reliable over the whole lifetime. If you want to go and see the approvals, then for the IC 6747-17, you can go to the VDE homepage. There we have got something that is called VDE geprüfte Produkte. There you can type in the certification number, and then you can directly download all documents, all amendments for our products directly without any charge. The slides here show the SOIC8 narrow body for you. Then for the UL 5077, you have to go to the Product IQ homepage. You have to register here, but here, if you type in then the e-file number, then you can get all the information about our products directly and always up to date. So now we know what products we have, what the products can do, how you can make the design in. What do we have additionally for you? In addition to the products, the digital isolators, we have a bunch of design-in tools that helps you to get here quicker to a time to market. First of all, our online catalog. As you can see here, you have got all the data sheets every time up to date. You have got all Red Expert data here. You have got also, in addition, all these EDA models, the CAD models that you can download free of charge. And to make a very good first sortation, you can also have here all the data we have shown you in the 6 essential parameters. You can check also here, and you can make then a sortation about what you need then for your design. Red Expert, as already mentioned, is our homemade tool, and here you can get all additional information that you can use for your design in. You also have here, let's say here in the tabs, you have got the EMC behavior, you have got the input-output characteristics, you have got here also some example application schematics, you have got here the picture of how the whole product looks like. And what you can also do is you can tick here some of the digital isolators, and then you can make a comparison so that you can always be sure if you use Red Expert. In addition, with our online catalog, you will find by sure the right digital isolator for your application. And for those who want to have it a little bit in the hand, we also have our digital isolator evaluation boards. Here we have the digital isolator board for our CDIP version, so our digital isolators with integrated power here. And what you can see is we have got also here a small EMC filter space for you, where you can put the SMD parts for the filter on it. You have got here the pin headers so that you can fill in your signals. This board is valid up to 100 megabits. If you don't want to put it here about the header pins, here you have got some space so that you can also go for edge-mounted SMA connectors. You can also take them. We have got the screw terminals, and also here the pin headers, or also here at the output the edge-mounted SMA connectors, so that you can get the signals out. In addition to this board, you will receive a quick start guide and also a document that guides you through all the things that you can do and that you should not do with the board in generally. The quick start guide here shows you, first of all, the schematic of the board. It shows you the complete bill of material and explains you all the functional units that you have on this board. The good here for the bill of material is if you need any part in addition, you have got here the order code, and you can get then very quick about our online catalog to make a sample of it. What else do we have as, let's say, additional knowledge? Recently, we released an article in Power Electronic News that somehow enlightens a little bit more in depth the applications that are needed for a digital isolator, the functions of a digital isolators, but also the different types of isolation techniques. Here I enlighten a little bit more the differences between optocouplers, digital isolators, capacitive, inductive technologies. And I also go here a little bit more in detail about the explanation about the, let's say, CMOS structure of the digital isolator. And also you will see here example applications for digital isolators. If you have got any additional questions that I cannot somehow answer you today, or you have got some design in runnings, please. We have got our support hotline here. Then we have got our 3 guys who do this for a very long time. And also, if there's any, let's say, sales-driven question, we have got our business development team here that is always for you there to help you and answer your question. For me, I will stay here for answering your question, and I hope you enjoyed my small webinar about the digital isolators and why they're needed. Thank you. So, some questions.
Thank you, Timur, for your interesting presentation.
Thank you.
Now we will come to your questions. Before we start with the Q&A session, I will share the handout from the presentation today. So now you can download it on the right side. Okay, then I think we can start with the questions. Oh, sorry. One moment,
No
a little bit.
That gives me time for a little water break.
Yeah.
Thank you.
So, no. Now, first question. Why did Würth Electronic choose the VDI for the digital isolators?
A very good question. As I mentioned in my presentation already, there are a lot of standards out there, but we saw after a deep investigation that this standard, the 6747-17, is the most demanding standard and the most up-to-date standard that covers these products. And as we, as Würth Electronic, are, let's say, there to bring only products out there that are really safe, this is the best standard for us. Hope this answers.
Okay, thank you. Then, next question. Does digital isolators have similar response to differential and con mode noise?
This is a very good question, but I think this is a question I would like to get in contact with someone who has questioned this,
no problem,
and or grab the phone with him and speak directly, because there is no yes and no answer. We have to check this more in depth.
No problem. Then, next question. What's the speed range at which a digital isolator can be recommended?
We have got the CDIS and the CDIP. Our CDIS are recommended up to 150 megabits per second. So that means you can cover all this stuff like CAN, like RS-232, RS-485, all this common automation buses you can cover with. And the CDIP with the powered one, they are up to 100 megabits per second. But this is also enough speed to cover all the well-known automation buses you have out there.
Okay, thank you.
Welcome.
Then, next question. Yeah. How high isolation voltage can the digital isolator achieve compared to go up to isolators?
Up to isolators. Okay.
Yeah. So.
There you have to understand the nature of both products. An optocoupler has got an LED and a receiver, and between both of them you have an optical conducting material, and that means it depends on this special material that between the LED and, let's say, the transistor, the phototransistor, and therefore it is somehow different because this material can somehow withstand high voltages, but it is a material that is somehow also in the region that if you have got higher temperatures, then also the CTR, that means the current transfer ratio, that means how the signals are going to be transferred from the sender to the receiver side, is going to be influenced, and also this material can alter somehow. If you go for a digital isolator, then you have got here a CMOS process. You have got also, let's say, smaller distances through the isolation, but the material that is there, like SiO2 or other materials, have higher isolation voltages per micrometer.
Mm-hmm.
But please check out the power electronics news article from me, as we have it there as a link in the presentation. I also speak a little about this here. If there is any additional question, please do not hesitate. Get to me directly, and then we can talk about this.
Thank you.
You're welcome.
Then, next question. Among commode choke and digital isolator, which one would be preferable for RS485 communication?
Okay, to be honest, the common mode choke is something that is a filtering element, and the digital isolator is an isolator. So I currently don't get the point of the question for RS485.
Mm-hmm.
Guessing the digital isolator is better because it is blocking the interferences. It is blocking somehow the common mode noise. So I would go here more for a digital isolator. But to be honest, I would like to get an information or an email.
Mm-hmm.
Please, one who has sent this a question, please send this by email with a little bit more explanation. Perhaps you have got a circuit diagram or something specific in mind, so that we can answer your question to the point. Thank you.
Cool, thank you. Then
I think we're done.
yeah, I think one question. This one. I think one last question.
Yeah, this?
Yeah. Can digital isolator maintain the isolation even when the maximum limit will be exceeded? Sorry.
No problem. If you, let's say, exceed or over-exceed the absolute maximum ratings, then there can be no guarantee that the isolation barrier is still there. Yes, of course, the tests we have done are with higher values, but this has to be, let's say, figured out more in depth from case to case. So there can be no general answer, or the general answer is if you exceed the absolute maximum ratings, then there's no guarantee for the isolation anymore.
Okay, thank you.
You're welcome.
Then I would say we are finished with our session. Thank you, Timur, for your interesting presentation and for the answers.
Okay.
If you have any questions more, you can write in the chat, or you can write Timur directly. And then I would say thank you for your attention. I hope you enjoyed it, and hopefully we see us on our next session of Digital Redays. And then I would say thank you and goodbye.